All right, now it says here, we're going to be going through this one. It says algebraically. Now, if in a test it says algebraically, that means do it by hand. Now, it says find the x-intercepts of the following. Now, we have this. We have y equals x minus 3 all squared minus 25. And to find the x-intercepts, we must let y equal what? 0. So we're letting y equal 0. And then what we're doing is we're solving for x. I might just give it a little bit of a zoom in. Now, we're solving for y equals 0. So let's do that. Now, whenever you have something in turning point form, which this is, if this value here, negative 25, was a positive, then would there be any solution? Yes. No, because if I subtract 25 from both sides, I'm going to have a negative answer. The square root of a negative is going to be, well, it doesn't exist, does it? So therefore, now if you think about it, what is this graph going to look like? Where's the coordinates of the turning point going to be? It's going to be 3 and negative 25, which is going to be, say, somewhere over here, and it's a happy quadratic, isn't it? So it's going to have that sort of shape. So just by knowing the fact that it's that shape, it would make sense that, yes, there are x-intercepts, and we can find them in this form doing it this way. Now, there's no point. You could actually factorise it as well if you wanted to. But what I'm going to do is I'm not going to factorise this using dots. I'm going to show you another way, and that is just solving for x. So what we're going to do is we're going to add 25 to both sides, which you should see is this, x minus 3 all squared. Now, when I take the square root of both sides, what's the square root of 25? 5. Okay, but how many solutions do we have? Is negative 5 squared also positive 25? Yes, so the answer is plus minus 5 on the left-hand side. There are two solutions. And on the left-hand side. And on the right-hand side, we have the square root of x minus 3 all squared is just x minus 3. Now we're solving for x, aren't we? So what do we do to both sides? We want to add 3. So therefore my two solutions are 3 plus or minus 5. Now I would not go ahead and leave it like that, because I would then say 3 minus 5 is minus 2. And then the other one is what? 3 plus 5 is 8. Okay? How are we feeling about that? So our answer is x equals minus 2 and x equals positive 8. I guess we would have 1 mark for working, and we would have maybe half a mark for each of those answers being correct. Now, if I was to solve that in a CAS calculator, which I do want to encourage you guys to start doing. Now, if I go to menu 3.1, we solve. And we want to solve the equation x minus 3 all squared minus 25 it has to be equal to something. There has to be an equation. We need an equal sign. If you don't have an equal sign and it says, and the calculator craps its stacks, it's because you haven't got an equal sign, most likely. There you go. X equals minus 2 and x equals 8. Now, when I write exam 2, I'm going to reward the students that can do it on the calculator, because they're going to have more time. All right? But if it does say algebraically, you must at least show your working, please. All right? Now, hey, if you want to ask about this again, you could always go ahead and watch the video. There's a few calculator skills I'm going to show you today, which it might pay for you to review over this. Now, it says here, find the x-intercepts. Now, I'm just going to pause this and we'll have a little discussion. We always try to factorise first.
Wait, so you can't use a quadratic equation?
You can always use a quadratic equation.
Yeah, but can you just use it straight away?
Yes, absolutely. Now, the thing is that this, to me, I reckon if you're trying to come up with two numbers which multiply to give, well, this times this, that's going to be a crazy big number. We could take, so I'm going to just use the quadratic equation straight away. Now, shh. Keep it down. Shh. First of all, the quadratic equation you guys need to know, or have in your bound reference. Minus b plus or minus the square root of b squared minus 4ac over 2a. Now, what might make... Now remember that if we're solving for... If we're solving for the x-intercepts, then y is equal to 0. So we could make our life a little bit easier by taking out a common factor first and then dividing through. So I'm going to think of that. What is the biggest number? I think, did we decide it was 2? Okay, so what I'm going to do is I'm going to make my life a bit easier, and I'm going to take out minus 2 out the front. Okay, I'll show you why. Now, you don't have to. It's going to still come out to be the same result. Let's have a look. If I take out minus 2, that gives me 9x squared minus, plus 42x plus 49. And look at that, it's equaling 0. Now look, I've just done this to make my life a little bit easier. What can we do to both sides now to nick that negative 2 off? Divide by. So what I have is I have a slightly easier expression.
Why do you have no negative?
Because I've divided both sides by negative 2. 0 divided by negative 2 is 0. Now, look, this is a strategy which... This is a strategy. Look, 23 voices all at once. It's just going to take longer. Now, we could then decide, if we wanted to, try to factorise. We could go 2 numbers which multiply to give 9 by 49. Okay, getting a bit ugly though. 9 times 50 is 450. Take away 9. Yeah, 441. So 2 numbers which multiply to give 441 and add to give 42. Yeah, yuck. Let's just go straight to the quadratic equation. Now the quadratic equation, the coefficient a is equal to 9, b is equal to 42, and c is equal to 49. So let's go ahead and chuck that into the quadratic equation and see if we can simplify. Now, I tell you now, you haven't been given enough room to do all of this. So if I had a question such as this, I would hope to God that you've got more room in a test. I think it's either way, we'll keep persisting. So what we have is our x-intercepts are minus b, which is minus 42, plus or minus the square root of b squared. 42 squared. You'd want to have a calculator, wouldn't you? I'll do it in my head though. 42 times 40, 1680, and then 2 times 42 is 84, so 1680 plus 84, 1764. Is that right? Okay. So you guys though, I don't expect you to be able to do that. B squared minus 4 times A times C. 4 times A times C. 9 times 49 is 441. 441 times 4. 441 times 4. What's that? 41 times 4 is 164. 164 plus... I can't be bothered. What is it? What's 40... What is it? What are we subtracting?
1,764.
Whoa. Is that true?
Yeah. It equals 0. What is?
Yeah, okay, good. Is that so that equals 1,764, is that right?
With the same thing happened.
Yes, it would have. Yes, you can try that. All right. Now, that's going to work out quite conveniently, isn't it? Now, what's 2a? 2a is what? 18. Beautiful. All right. Now, what a lot of people do is we clearly say that that's minus 42 plus or minus 0. That's right, over 18. Now, what we can do now is we can say that is... How many solutions are there? There's one solution. And in other words, this b squared minus 4ac, the discriminant 0, what does that mean? It means that there's one solution. So therefore, the x-intercept just one sec. The x-intercept is how many times does 6? So that's going to be negative 7 over 3. Yes? Just one sec. I'll just pause it, matey. On a CAS calculator, what did we have? We wanted to go menu 3, 1 for solve. And didn't we have negative, if we solve that, negative 18x squared, what was next? Minus 84x. Minus 98. And we're solving for that equaling 0, comma x. And what do you get? Voila. Too good. But I would have expected 3 marks, 2 method marks. So one mark for the answer in a CAS calculator if you want to check your answer, but 2 marks for the method. All right, that was a tough one. Now, what do you notice about this one here? So just explaining that method, we've taken out x minus 6 as a common factor. Quite a few of you, if you wanted to expand it out and simplify and then expand, but then we're just factorising a monic polynomial and then using null factor law. Otherwise, Joel, if you equated that equaling 0, let's have a look and see what the CAS says. Menu 3, 1, and it's, what was it? It was x minus 6 all squared. X minus 6 all squared plus 5 times x minus 6 plus 6 plus 6 is equal to 0, comma x, and you should get 3 and 4. All right? Good. Now look, a couple of toughies there, because you need to decide how am I going to go about this. In the first ones, one of them we use the quadratic equation. The other one we might decide to complete the square.
I just left it in exact form.
All right, so what we've got to do is we've got a sad quadratic, but we don't know what the turning point is. So I've decided, don't have to though, I've decided that I'm going to complete the square first. In order to complete the square, what we're going to do is we're going to take out, I have to take out a half, negative a half, as a common factor, because otherwise I can't complete the square. I've got a positive x squared there. Now negative a half times what is going to give me positive 2x? Or sorry, positive x. What is it? Minus 2x or positive 2x? Negative 2x. Good. And what's left over? A half is 0.5. So what would I have to multiply negative a half by to get 1.5? Negative 3. Yeah? So we've started off here, and now what I'm going to do is complete the square. But remember, that negative half doesn't go anywhere. That needs to be dealt with. Okay, so what we're going to do is we're going to halve, square, and add, but using our square brackets. Half of negative 2 is negative 1. So we're going to go x minus 1 all squared. Then I need to subtract that 1 squared. Okay, or it's actually subtract negative 1 squared. Okay, and then I need to, that negative 3 doesn't go anywhere. Now what I do is I go ahead and I simplify those numbers inside the brackets. So I've got that negative a half there, it still stays there. I've got x minus 1 squared. Now be careful, negative 1 squared is positive 1, but then there's a negative out the front. So it's negative 1, negative 3, which is negative 4. Now, this is not in turning point form yet, because we need to multiply that negative a half by everything. So now, if we do that, negative a half, x minus 1 all squared. Just one sec. And then we're multiplying negative a half by negative 4. Now negative a half times negative 4 is positive 2, isn't it? Okay. Now, if I have a look at that, if I'll just pause it for a sec. Now, so what we know is this is in the format of y equals a outside of x minus h all squared plus k. That's turning point form. Now, this value here is k, and it just so happens to be that h is 1. So, in other words, so what we've got is we've got a turning point at 1, 2, and just so we know, we also know because that a is a negative value, it's a reflection of the graph x squared, or even the graph x minus 1 all squared plus 2 in the x-axis, which means we've got a sad quadratic. Now, what I would suggest you do at this point, so we get an idea, is we do this. Mark out, okay, this is my x, this is my y, 0.12 is, let's just say that's here. All right, so that's the 0.12, and we know that that's going to go something like this. Now, the problem is, though, we don't really know yet where the y-intercept is. In actual fact, we do, because the y-intercept is when x equals 0. What's the y-intercept? 1.5. Nah. You're sweet. So, what we're going to do is I'm going to put that value there as 1.5. So, in other words, we're going to have a quadratic which looks something like this. All right? And it's going to go there, and we know that it's going to go somewhere over here. But the problem is, without finding the x-intercepts, you're probably best not to do that yet. We can adjust this anyway. Now, since we've gone to the effort of completing the square, you are stupid. Sorry, you are silly. You are silly if you then go ahead and use the quadratic equation, because the quadratic equation is just a shortcut for completing the square, and we've already completed the square. So, what we're going to do is we want to find out, we've found the turning point, we know the shape. What we've got to do is we've got to find the x-intercepts, and by finding the x-intercepts we have to let y equal 0. But hey, don't go letting y equal 0 for this. Let y equal 0 for this. Okay, so what we're going to do is we're going to let this equal 0 in turning point form. We've done the hard work. We don't have long to go. Now, we know by looking at the graph then there's going to be 2 intercepts. So what we're going to do is we're going to solve for x. So what are we going to do? We're going to subtract 2 from both sides. So we've